Today, I'm talking to a friend of mine who is working as a computer vision developer, engineer, something.
Yeah.
And he will explain it later. And welcome, Enes.
Hi.
Can you briefly explain what computer vision is?
Yeah. Hi, everyone. I am Enes. I work as a computer vision engineer. And what computer vision is, it's actually an area that to understand images inside machines, how machines can see the world. So we use images and videos and try to get information from those images. Actually, that's the general concept of the area.
In the computer vision area, I assume that there has been so many changes throughout the history. What did computer vision look like before deep learning and all these AI stuff?
Yeah, so all these AI stuff, before all of these, like we were in a dark actually. So we don't have automatic one-shot, zero-shot learners back then. So there was only classical methods like mathematical analytic approaches on images. For example, to understand something about the image, we have image kernels like edge detection, or we have some other feature extraction methods, face detection, Haar cascades, optical character recognition, OCR. These were all back then without any deep learning. We were just using handcrafted features and mathematical approaches. Even today, we are using OpenCV, which is a very popular computer vision engineer tool. Every computer vision engineer should know OpenCV, and inside the OpenCV, all of these classical methods are already integrated and developed, so we don't need to build them from scratch. They are all here to use.
In deep learning, when you train the models, you still use those methods, at least some of them. Am I right?
Yeah, so for pre-processing and post-processing, we use the classical methods a lot even today. But like actually everything starts with AlexNET, and the convolutional neural networks. Before then, we didn't have much data and we didn't have any structure, any architecture that can trainable. So everything was handcrafted. Then with the AlexNET, we see that with a lot of data, we can train self-learning systems. There is an international competition about computer vision area actually. It was called ImageNET. So this challenge, it has thousands of images and everyone trying to classify these thousands of images into 80 different classes. There were some classical methods, different approaches, but AlexNET actually created that spark about convolutional neural networks. And after that, we get YOLO models. Before that, we have CNN networks, RCNN, faster RCNN. So with the convolutional neural networks, we started training these systems actually. With a lot of data, labeled data, we can train these systems. We don't need any man-made features anymore. So every feature will be extracted from the data automatically.
You mentioned YOLO. Can you describe what YOLO is? I assume it's not you only the ones.
Yeah, YOLO, for the industry, it's a very big step actually, because before YOLO, we have lots of convolutional neural networks and other things, but they are in the academic side because they were running very slow. And in the real life, we are live camera feeds. So we need a model can run in real time. So with YOLO, we get these models. They can run in real time, very small and with good accuracy. Yeah. So YOLO started maybe 10 years ago, but even today, most of the real-time application relies on YOLO.
I myself also have trained an object detection model myself to use on my mobile app. I used YOLO for it. I've been able to export it to TensorFlow Lite, if I remember, and it ran really well on my mobile phone.
Yeah,
mobile
so
app.
The history actually began with image classification, looking at the image and trying to classify the image type actually,
Yes.
in maybe 80 different categories. Then we get with the RCNN models, like we get object detectors. With object detectors, we don't actually have one classification, we can have multiple different bounding boxes inside the same image. And after the detectors, we got other complex models as well, like segmentation models. And even today, with the new AI trends, right now we have VLMs, like it's very big models that can understand everything without training.
So before VLMs, you had to, I think, involve the transformer and another encoder, I suppose.
Yeah.
Right? So you had to feed the data into the transformer using an encoder, right? But
Yeah.
after VLMs, that has changed, right?
Yeah. Firstly, we were just getting a lot of data first, labeling them, and then training a model.
Yes.
Mostly YOLO models because they are running in real time. Then using those models with the data. But after that, right now, we don't need too much image label anymore because we have very complex models. Before visual language models, first LLMs came. And LLMs are text input, text output models.
Yes.
Before the multi-input models, we need a hybrid solution for converting images to text representations. That's why we have image encoders. Like these image encoder models like Clip and Blip, they are just essentially getting the image and converting them into tokens, representing them in an embedding site. So then we are using this tokenized version of image to give it to an LLM and get the response. The first models about image captioning. So you give an image and the LLM with the help of the image encoder is captioning that image. But right now, like we can ask anything as a prompt.
Now we can even generate videos.
Yeah.
Right.
Yeah.
With Sora, at the time of recording this, Sora can only generate videos up to 5 seconds without a sound. But Google's Veo,
Veo 3, did you try it? It's awesome.
I tried, it's
So
great.
it's not only video, so generative AI, like back then when I'm at university, my graduation thesis was about GANs, generative adversarial networks. But right now we are not using GANs anymore. Like it was the first baby version of generative AI actually back then. But right now we have diffusion models, vision transformers, and right now models are multi-input, multi-output. So with Veo 3, for example, only a text prompt, we can get image, video, a voiceover, a sound, everything in a video.
So what are your predictions about the computer vision field? Where do you think it's going to go? Are we going to see more AI tools in the area?
Yeah, exactly. It's a very, very crowded area right now. Like everyone is creating their own version of the model. Generative AI maybe not currently doing anything on enterprise side, but VLMs, like visual language models, it's the way it's going actually. Like we can use a VLM and ask the model anything about the image and it will answer it.
Thanks a lot for the info, Enes.
Oh, thank you for having me, Samet. Thank you.